Welcome to this online lecture. If you're struggling with the general mechanism for electrophilic aromatic substitution reaction, this is the right video for you. In this online lecture, we're going to talk about the definition and the general mechanism for electrophilic aromatic substitution reaction. Before we can even talk about the general mechanism for ES, we need to know what ES is. And so, what is electrophilic aromatic substitution reaction? Well, this is a reaction in which the hydrogen atom of benzene is substituted by an electrophile. This means that for us to perform ES reaction, we need to have number one, we need to have benzene or any aromatic compound. We also need to have an electrophile and also a Lewis acid. If we have these three things, ES reaction can take place. Now notice what is happening here. What we're basically doing here is that we're just replacing the hydrogen atom of benzene with an electrophile. So this is basically what ES is all about. It's just about replacing the hydrogen atom of benzene or any other aromatic compound with an electrophile. Now, to have a better understanding of this important reaction, let's look at the general mechanism for ES. What you're seeing here on the screen is a general layout for ES reaction. So to understand how this hydrogen atom of benzene is being replaced with an electrophile, we need to look at the mechanism, the general mechanism for ES reaction. Now, the general mechanism for ES reaction involves three steps. Step number one involves electrophile generation. Step number two involves formation of carbocation. Step number three involves deprotonation. Let's dig deeper by looking at these three steps in details. Step number one involves formation of electrophile, and this particular step involves a reaction between an electrophile with Lewis acid to form a completely developed electrophile. So this is basically what happens during this step. We just want to have a fully developed electrophile. Benzene is stable, and so we need to have a very strong electrophile which can react with benzene, which is stable. And that's why this step is important, because it gives us a very strong electrophile which can react with benzene. So now we have benzene right there. This benzene is attacked by an electrophile which is formed in step number one. 2 pi electrons from benzene are used to form a sigma bond with the electrophile. And when that happens, we have a new structure which is being formed, and this particular structure that has been formed is a carbocation. Now this structure has resonance, and so the electrons can move. Delocalization of electrons can take place, and so you can see how the pi electrons are moving to form that particular structure. That structure which is also formed also has resonance, and so the electrons can also move in that manner to form that particular structure. It is of paramount importance to know that this particular step involves resonance stabilization. The carbocation which is formed is resonance stabilized. Okay, let's go to step number three now. Step number three involves deprotonation. In this step, a proton from the carbocation is removed by a base to restore the aromaticity of the benzene ring. So this step is just about restoring the aromaticity of the benzene ring. Let's see how that is done. So we have that carbocation which was formed in step number two. A base comes in to get a proton, and these electrons which are left behind are used. You can see these electrons are going to be used to restore the aromaticity of the benzene ring. So this is step number three. In a nutshell, what we're basically saying is that the general mechanism for ES reactions has got 3 steps. Step number 1 involves generation of electrophile. Step number 2 involves formation of the carbocation. You can see how the carbocation is being formed. You have benzene and also the electrophile, and these pi electrons here are used to form a sigma bond with the electrophile, and when that happens, a carbocation is created. This carbocation which is formed is resonance stabilized. Step number 3 involves deprotonation. So this is where the base comes in and gets this proton, and these electrons are used to restore the aromaticity of the benzene ring. And now we have our final product, which is shown here. So this is how the hydrogen atom of the benzene ring is replaced with an electrophile. It's a very simple mechanism. In later videos, we'll talk about the different types of ES reactions. All these reactions that you're seeing here are the types of ES reactions that we have, the most important ES reactions. Okay, so when we look at these reactions, we'll be able to see that all these reactions follow the general mechanism for ES reactions. The same general mechanism that I've outlined in this video is followed by all these particular reactions. For more cool videos, please subscribe to my YouTube channel.